Hi, I'm Chris Chedji. I'm a product manager at Sonar. There was a talk by Olivier where he described Sonar's approach to architecture, a new feature in the product. What I'm going to show you now is the product itself in action. Sonar architecture comprises basically three main capabilities. The current architecture is extracted automatically from your source code with every scan. So it's always up to date, and it shows you a representation of the containment structure and relationships in your code. Intended architecture is something that you create. So what it lets you do is put some of your containers within your code under control and define their allowed relationships with other containers. Deviations are detected and reported as anywhere where the current architecture deviates from your intended architecture. And they will be listed in the Sonar architecture dashboard, and they will generate SonarQube issues for the developers, bring the developers to the exact lines of code where there are references that are inaccurate, that are not conformant with the intended architecture. So they will have the information they need in order to repair the code and bring the current architecture in line with the intended architecture. This is intended to be an iterative, continuous process. So you can start with your intended architecture, put in your priorities, and then when any deviations from that are addressed, you can extend the intended architecture and continue that process. The architecture within Sonar has its own dashboard. You can see it here, and the three main capabilities that I just mentioned are current architecture, intended architecture, and deviations. I'm going to show you what these look like for a Java project. So I'll be using terms like classes, packages, modules. You can translate those to your own ecosystem as files, folders, namespaces, and so forth. The current architecture then is this. It's basically a map of your whole code base, whereby the containment, the structural containment is represented by containment. So classes here, these are classes at the deepest level, are contained within their packages, within high-level packages, and ultimately within modules. The relationships drive the layout. So what that basically means is that for the most part, dependencies will flow from left to right. So for instance, here within the scope here, this item on the far right-hand side here probably has no relationship and no dependencies on any of the other things in this package. And any of the classes in each of the other classes depends on at least one class in the row to its right. And any classes here that are in the same column have no dependencies on each other at all. And this is applied at every level. So you can say the same thing about these packages here. This package has no relationship on either any of these packages, and all of these classes in this column here have no dependencies between them. You'll also spot wide areas here where you have chains of dependencies. You can recognize this quite clearly, that this package depends on code in this package, depends on code in this package, etc. So you already get a good feel for the overall relationships and containment structure of your code base. And the size sort of more or less represents the amount of code ultimately contained by any container. You can see specific dependencies by clicking anything in the map. So in this case, I'm looking at the classes. A class here I clicked, and it shows me all the other classes that it uses or is used by, or packages, or indeed modules. Now, when you start clicking on high-level components or containers like modules, it'll cause a lot of dependencies to be displayed, and it can be pretty hard to see what exactly is being used there. You can switch to high-level mode here, which gives you this view. Basically, those lines are replaced by highlighting the nodes that are involved in the relationship with the selected item. Also, anything inside this module that uses something or is used by something external to the module are also highlighted. And you can narrow the scope by clicking on, for example, in this case, a package. What does this package use that is external to this module here? Well, here they all are here. Okay. Final thing I just want to show you is you can pan and zoom on the model here. Now, obviously, when you zoom in, you're starting to see more details. You're seeing the names of all the classes and that type of thing, but your screen is only so big, so you're going to see a narrower field of vision. Where dependencies go off screen, you can pan to go find those, or often more useful is you can zoom out, see where they go, and zoom in if you want the names. This lets you kind of basically follow dependencies across your whole code base very easily and very quickly. So basically, the intended architecture, it's a map, it's very easy to browse. You just pan, zoom, and click. So now let's take a look at the intended architecture, where we're going to start putting some of our code under control and defining some relationships. When you first go into intended architecture, you're seeing this as the model. It's basically an empty model, but there is one box in the model for each language that is found in your code base. This is a pure Java project, so we just got one box here. And what I'm going to do is start adding in a subset of my top level components first into my model. As I'm going, I'm just clearing a few checkboxes. You don't need to worry about why exactly I'm doing that. It's just to make the demo go a bit smoother. So I've added in 3 of my top level modules here, and now I need to define the relationships between these modules. And what I want to say is basically parser and integration can both use the API. But by inference, I'm also saying that API shouldn't use either of the other two. And integration, for example, if there was some code found in integration that used some of the code in parser, that would be a deviation from my intent here, because there is no intended relationship shown in my model between those two modules. I can also go deeper into the structure. Again, I just continuously click deeper in, and I'm going to add a few packages here that are all at the same level into my model. I wanted 3 of them. And just one more is VMOps. Okay. And again, I need to define the relationships between these packages here. So what I want to say is, well, JVM can use unified, and that's it. I want VMOps to have no relationships at all with either JVM or unified. You'll notice as you're adding relationships, you can only add relationships between siblings within your model. Basically, any more distant relationships are already covered by the intended relationships at the parent level. Okay, before you finish here, and in order for this to be picked up by your scanner to check for deviations, you do need to save. So I'll do that. And then once you've run your next scan, you'll see potentially some deviations being reported here. The ones I just added are causing this relationships deviations to be created. And I can see here what they look like. I've got one here from the integration module to the parser module. Something in there uses something in there. And likewise here, I've got something from the VMOps package to the unified package. And you can always click through here to see the any Sonar issues that are created. These are the code level. These are the code level references that are causing that unintended reference in the code. Now, going back to architecture here, I'm going to extend my my model now. I want to show you another category, if you like, of structural control that you can express using the intended architecture, and this is basically structural changes. We've done sort of relationship changes, structural changes where you want to create new items in your code, or you want to rename things, or you want to move things around. And they're all available on the context menu for any of the components in the model. What I'm going to do is create, first of all, a placeholder. So this basically is a situation where I want to create a new module in my code base. It doesn't exist yet. And I'm going to call it GC Toolkit extension. And the advantage of doing this is maybe there's a new module that we have decided that we're going to create. So rather than just continuously growing the existing modules, you're occasionally going to want to add new modules. But I can, by adding it to my model now, as soon as any code is added to my new module, its relationships will be checked here. And what I've basically done here is I've hidden it behind the API module. So I'm saying that these modules here should not directly use the extension. They should go through the API. And this will kind of force the situation where if some of the functionality is required in the new functionality that's being added to extension is required by something inside parser, the inclination may be to directly use it, but that'll be prevented. And the developers will be thereby encouraged, if you like, to maybe extend the API so that to allow access to the new features. Now I'm going to show how you can move stuff around. So go from the current location. Let's say I want to move this IO, this existing IO package, which contains just, if I look here, it just contains a single class. But this actually, we've decided this should really go into this new component here that we just added. I can just go ahead and move it, select the extension and do a move. And that expresses what I want. I want a new module called extension. There's going to be an IO package in there. And by the way, the code in there should be moved from its current location in parser. I've just said all of that. And the SonarQube issues will drive the users to make that change. Let's see what these structural changes look like in the dashboard. And here they are here. You can see that IO is there. This is one where actually I did a renames of JVM utils, and you can always click through to see the list of the issues that are raised that will cause that rename to happen in the code and bring it in line with what we specified. So finally, I'm going to talk about the flaws here. So flaws kind of lie in between the current architecture and the intended architecture. They look at the current architecture and spot certain patterns that could be considered problems, and they list them down below. At the moment, we only detect one type of flaw, which we call tangles. You can expect this to grow in the future. Tangles are basically a group of classes or files that are cyclically dependent on each other. That is, they either directly depend or indirectly depend on all of the other classes within the tangle. Let's take a look at what one of those looks like. So here you're seeing the 5 classes that comprise this tangle here with their dependencies grouped by the packages that contain the classes. And you can see, for example, there is a path from every class here to here, to here, to here, and back to itself. All of these are cyclically dependent. We're just going to take a look at one slightly simpler tangle here. This one here, you can see all of the relationships flow from left to right, except this one that flows from right to left. If this one was to be removed, what would be remaining would not be a tangle anymore. There would be no more cyclic dependency. And I can go ahead actually and directly request that that be removed. We call that a directive, which will be surfaced as a Sonar issue where the developers are taking to each reference within that file that caused that class-to-class dependency that we've asked to be removed. Okay, that's it. I think we've covered all of these now. Please go ahead and take a look at it. You may want to take a look at your current architecture, explore the map, and get a good feel for how your code really is structured today. It'll be very convenient for onboarders and that type of thing to help them understand how the code is organized and how the relationships are within the code and that type of thing. The intended architecture, you probably want to start with a few high-level components, put them into your intended architecture to find the relationships, see what deviations are reported, tidy those up until your code and thereby the current architecture is in line with your today's intended architecture. And then you can go ahead and extend that intended architecture, perhaps add some more high-level components or selectively go deeper, depending where your priorities are. And yeah, please try it. Let us know if you have any feedback at all. Very welcome. Help us improve the product. Let us know what you find most useful, what you find most frustrating, and we'll see what we can do about that. Thanks very much. Bye-bye.